Hello and welcome. In this lecture, we will set up and test autoscaling. What is autoscaling? It's an AWS service that allows users to define a minimum and a maximum number of instances associated with a particular load balancer that should be running at any given time. It allows us to define criteria by which boxes should be created or terminated. For example, we could say that every time the CPU on a box goes above a certain threshold, then AWS should spin another box, and every time it goes below a certain threshold, it should remove an instance. This also implies that every time a box goes down for whatever reason, AWS will spin another one up until it reaches the minimum number. This makes it for very resilient and self-healing environments. Gone are the times when system operators got a call at 2 AM because a box went down. With autoscaling and elastic load balancing, AWS creates and removes boxes dynamically. Let's see how this works. From the previous lecture, you should now have 2 Spring Boot boxes, each running in a different availability zone, as well as 2 Apache HTTP boxes, each in a different availability zone. You should also have an internal and an external load balancer, the former in front of the Spring Boot boxes and the latter in front of the Apache HTTP servers. Finally, you should have 2 MIs, one for Spring Boot and one for Apache HTTP server. Before setting up autoscaling, we will terminate all Apache and Spring Boot instances currently running. To do so, right-click on the instances and select Instance State Terminate. To set up autoscaling, we first need to set up a launch configuration and then an autoscaling group. From the EC2 menu, select Launch Configuration and then click on the Create Autoscaling Group button. This time, rather than selecting an Amazon MI, click on the My MIs menu and select the Spring Boot MI. The My MI menu shows the MIs that we have created previously. Next, select the T2 micro instance type and click Next. As launch configuration name, you can enter Spring Boot launch configuration. As IAM role, select DevOps Buddy Full. Do not select the Enable CloudWatch Detail Monitoring checkbox. In the advanced details, enter the content of the Spring Boot mi init.sh script that I have attached to this lecture. Next, select Do not assign a public IP address to any instances. Since we are creating a launch configuration for the Spring Boot application, we don't need this to be reachable from the internet. Then, click Next twice. As security group, select the Spring Boot security group. Finally, click Next and accept all the defaults until the launch configuration has been created. Now, AWS will ask you to create an autoscaling group. You can call the group name Spring Boot Autoscaling Group. You can select 2 as initial number of instances. Next, we will select DevOps Buddy as VPC and the 2 Spring Boot subnets. This means that the autoscaling group will create instances where there's more need. For example, if an instance died in an availability zone, AWS will recreate an instance in that zone. Next, expand the Advanced Details option and check the Receive Traffic from Elastic Load Balancers checkbox. When the text field appears, select the Spring Boot Load Balancer. As for the health check type, select ELB, that stands for Elastic Load Balancer. There is generally a short delay between the moment a box is marked as running and when the load balancer considers it healthy. For this reason, it's better to rely on the status returned by the load balancer rather than the EC2 status, since when the load balancer says the instance is healthy, it means we can start using it. Next, select 200 seconds as grace period. Once done, click Next. In the Scaling Policies screen, select the Use Scaling Policies to adjust the capacity of this group and enter 2 as minimum and 5 as maximum number of instances. Next, click on the Add New Alarm link. Here, you can decide to send a notification to an SNS topic. In our case, I'll uncheck the Send Notification to checkbox, but you can use the SNS topic to send SNS notification via email to your email address. Next, I'll specify that if the CPU goes above 80% for one consecutive period of 5 minutes, AWS should spin up another Spring Boot box. I'm going to name this alarm High CPU Create Box. Then, I create the alarm. Next, I will instruct AWS to add one instance when the alarm goes off. Next, I'm going to create an alarm to delete a box, following the same process. I set up an alarm when the CPU goes below 40% utilization for 2 consecutive periods of 1 minute, which is the same as saying every 2 minutes. I'll name this alarm Low CPU Remove Instance. Next, I'll create the alarm and instruct AWS to remove one instance when the alarm goes off. When finished, I click Next. Here, I might want to get notified when AWS successfully launches or terminates an instance, or when it fails to do so. In this case, I leave it blank as I like to avoid email spamming, and then I click Next. In the tag session, I'll enter the tags name with value Spring Boot Server and visibility with value private, making sure that the tag new instances checkbox is selected. Finally, I click Next to review my autoscaling configuration and click on Create Autoscaling Group. As an exercise, I like you to set up a launch configuration and an autoscaling group for the Apache HTTPD servers. Use the following guidelines. Remember to select the Apache HTTPD MI and not the Spring Boot MI from the My MIs menu. Every HTTPD instance should have a public IP address. At startup, each instance should execute the instructions contained in the Spring HTTPD MI init.sh script that I attached to this lecture. You can reuse the alarms that you have used for the Spring Boot autoscaling group, or you can create new ones. Remember to select the public security group and to receive traffic from the public load balancer instead of the internal load balancer, and to select ELB as feedback type. Finally, the tag name should have value Apache HTTPD server and the visibility tag should have the value public. Please pause the video now and try setting up an autoscaling group for the Apache HTTPD server by yourself. When done, resume the video. If you get stuck, you can resume the video and follow what I'm doing. I'm now going to show you what I've done by accelerating my actions in the video so as not to waste too much of your time. Try to follow my steps to either validate what you have done or if you couldn't do it for yourself. You will notice that once you have completed an autoscaling group, it automatically launches the minimum number of boxes using the MI that we have set up in the launch configuration. Once the boxes are up, you can try the application by hitting the public load balancer DNS name. The DevOps Buddy application comes up. Now we can test autoscaling in action. Try to terminate one Spring Boot instance and one Apache HTTPD instance. After a few minutes, you will notice that AWS Autoscaling spins up these two boxes. In the meantime, if you keep trying the load balancer, you will see that the application is still up and running. I'm now going to pause the video until AWS has spun up a couple of boxes. That's it. That's the magic of autoscaling and elastic load balancing. Instances are maintained for you by AWS between the minimum and maximum number. They get automatically registered, deregistered with the load balancer. To conclude this lecture, I'd like to point out a couple of points. To have a proper high available architecture, we should normally select 3 availability zones. This also means creating 3 private and public subnets. For the database, we should normally select the multi-availability zones selection. This results in RDS replicating the database to at least 2 availability zones, so that if one goes down, the other one is immediately available, generally within few seconds. This means that our application can always be up and running. We didn't do this in this course as there is a cost associated with multi-availability zones in RDS setup. Thank you for your time, and I see you in the next lecture.